Okay, class, this is about transistor. Okay, so is what I explained in our Zoom class. Transistor is kind of like sandwich that you have NPN or PNP. Okay, NPN or PNP. So P positive lah, N negative, right? So the major charge carrier for P-type semiconductor, you know, as hole, and n-type will be extra electron. Okay, electron. So when you have PNP, you put it all together, this is what you call transistor. So how are you going to draw the symbol? Okay, the symbol of transistor look like this. Okay, you see that the P here will be at the bottom, and then N will be here, and this is P. So P and P, we always look at the two bottom terminal. You see that P and N, the current will flow from positive to negative, right? So the arrow will be drawing in this direction. How about NPN? So you look at NPN here. Okay, so NPN, current will flow from positive to negative, right? So you have to draw your symbol as this. So how you recognize whether this is NPN or PNP? You just look at the two bottom. If the arrow pointing downward, means that it is P here and it is N here. When the arrow is pointing upward, so it is from positive to negative lah. So we know that this is PNP transistor and this is NPN transistor. Okay, so what is the function of transistor? Okay, it can be amplifier. It amplified current for probably 1,000 times. Okay, so when we connect transistor, okay, we have to, let's say this is what transistor is that? P will be here, N will be here, right? So this will be NPN transistor, right? So we have to make sure that the two terminal at the bottom we connect it correctly, and the one that above we connect it wrongly. We purposely do it so that this is reverse bias and this is forward bias. If you still remember diode, reverse bias means that you connect it wrongly. So you see that this one we want to connect it wrongly. So N we have to connect to positive, so it is wrong lah. And then I connect it like this. You see that negative, shorter, right? It connect to negative here. So this one connect correctly. And then this one will be, okay, of course you can put another battery or whatever here. And this is positive and this is negative. So you have to make sure that you connect two at the bottom correctly, and then the above you have to purposely connect it wrongly. Then only the transistor will function perfect. Okay, so this is what you call base terminal, and this is what you call base circuit. Okay, and this is the main circuit, and normally our electronic gadget or our devices will be placed here. It will be connected here. Okay, so now I'm going to explain how this thing works as a current amplifier, and also it can work as automatic switch. Okay, so now we still go back to NPN. Okay, so you know that this is NPN, right? Normally in exam, the question will not label NPN, but you know that if the arrow pointing downward is from positive to negative. Okay, so if I'm going to connect a battery here, okay, and then let's say I connect a microphone here, let's say, microphone, I'm going to sing, right? So when there is current flow to in base circuit, then there will be current flow in the main circuit. Okay, so if the current flow through here, a small current flow through here, then it will be huge current flow through here. So if there is normally this base circuit, the current can be very small, microampere, and then here can be milliampere, so it is 1,000 times different. Okay, if there is no current, then there is no current here lah, in the main circuit. So we see that if you have input here, you start to see the current will flow through here, and it will amplify the effect of your sound. Okay, and then this is microphone, this is speaker here, then you can produce a louder sound. That is how you make this amplification possible to happen. Okay, another function is as automatic switch. Okay, so as automatic switch, we have two types. One is light sensor, light sensor. So light sensor, we have LDR, light dependent resistor. So LDR, it has a characteristic that when it is at night, and normally draw star and moon nighttime, right, the resistance will be very high. When it is daytime, the resistance will be very low. Okay, so now again I draw the transistor here. Okay, and then I have to place two resistor here. This one will be act as this potential divider, and this one I will put my light bulb here, and this is how I'm going to connect my circuit. Okay, you see that during night time, when the resistance is very high, this side will be very high, right? Because during night time there's no sunlight, resistance will be very high. When the resistance here very high, the voltage here or the potential difference here will be increasing also. Because if you still remember, I actually show you the calculation. It is potential divider. So this is R1, this is R2, let's say. So it's total, let's say this is V2 law, of course. So V2 will be equal to R2 here, R1 plus R2, and then times the total voltage that produced here. So this is how potential divider working. Okay, how it works. So if the resistance here very high, of course the potential difference here will be very high. So when the potential difference here very high, current will flow. When current flow, it will actually make the light bulb here to light out. Means that when it is night time, the resistance will increase suddenly and slowly increase, and then it will actually activate the whole circuit. Okay, if it is daytime, the resistance here will be dropped, right? So when the resistance here reduced, the potential difference here will be small. Then the current will be very small and no current flow through here. It's how it functions as a light sensor. Remember that when you want to make it light sensor, your LDR must be placed at bottom. Then only it light out the light bulb during during nighttime, and it will switch off during daytime. Okay, our last one. It is about thermistor. Okay, so you have to remember thermistor is a resistor that's very sensitive to heat. When it is very hot, when the temperature is very high, resistance will drop. It is like not normal ohmic conductor, we know, right? So it is like opposite. When the temperature is very high, the resistance drop. So when the temperature is very high, the resistance drops. So I have to put my LDR here. This is how I draw my LDR. Okay, and this is resistor and this is resistor. Okay, so you see that when the temperature is very high, I draw fire. When the temperature is very high, what happened to the resistance? The resistance will drop, right? So the resistance here drop, the voltage here will drop also, right? So when the voltage here drop, means that the voltage over this side will be very huge, right? So when the voltage is very huge, the potential difference is very huge, current will flow through, and it will activate the main circuit. Okay, then you probably put siren here, and then you start to alarm that the temperature is very high. Okay, so you have to remember few things. First, you have to remember thermistor, when temperature is very high, the resistance will drop. When resistance drop here, okay, this side, in the best circuit, potential difference will increase. When potential difference increase, current flow. When current flow, it will activate the main circuit, and then the speaker will sound lah. That is how it works. Okay, so if this is 4-mark question in exam, you have to answer one by one. First, you have to tell me what is the characteristic of thermistor, and temperature increase, resistance decrease. Okay, this is 1 mark. Second point, you said the potential difference at the best circuit will increase. When the potential difference in best circuit increase, the current will flow through. When current flow through here, then current will flow through in the main circuit. Okay, point by point you explain. Okay, that's all, class.